Hi, my name is Zoe Rose. Technically, I'm a cyber consultant at Baringa Partners. I would like to say I'm actually a terrible consultant. I don't really understand PowerPoint, so you will find that quite boring. But I'm a ethical hacker, Splunk architect, Cisco champion, something. The main important takeaway for who I am is I have 3 ferrets and they're absolutely adorable. I got into tech through more of a self-taught, this is really weird, more of a self-taught, so some things I understand, some things I don't. I'm learning as I go, so, don't judge me too harshly. Technically, I've been in technology for 10 years now, but I like to pretend I'm brand new, so yeah, then people don't judge us harshly. Okay, so today I'm going to talk about the foundations of network architecture, the basics, considerations for building your network securely with privacy and security by design, considerations and principles, and a couple of common attacks that you often see in a network. Not looking at it from the outside, because we're quite good at, it's really annoying me, we're quite good at blocking from a hard outside. We're not so great at actually securing the inside of our networks or understanding what exactly they do. My very first job with a development team actually came about because I owned my own company and I wanted to make money, so I took every job. The interview for if I was the right fit for them as a consultant was, they're like, okay, so theoretically, if your switch dies and you only have 2 small switches and you need all the ports on it and you plug them in together, and before they finished the question, I said, okay, well, do you have spanning tree protocol turned on? And they're like, no. It took us 3 days to solve that problem. So, as you can imagine, that is a nightmare. So I apologize if this is a bit too basic, but I'm starting from the very foundations of understanding how the network works, how it connects, and also things that are valuable. You don't need to read this, but these are like Wikipedia definitions of what is a router, what is a switch, what is an access point. If you don't know what these are, brilliant to look into it. I'm not going to define them, besides the fact that a router is on layer 3 and 4, a switch typically is layer 2. I'm also going to cover layer 3 switches, because networks typically have a lot of switches now, and an access point, because those are important. I'm not going to go into a ton of detail what a firewall is or what it does, because if you're deploying a firewall, you should know a lot more about the network before you do it. But firewalls, again, very important. They're often not well understood, and they're often just kind of put in place, sometimes doing something, sometimes not, and never looked at again. That's not a good idea. If you are deploying a firewall, it's a continuous effort. So the other thing I want to define in the beginning is a broadcast domain. A lot of people don't know what that is. If you do, I apologize. But basically, you're connecting at layer 2. If you send out, for example, a broadcast to find out which devices are on the ports, it's going to send it to everything. That's good, to find out where they are. It's not good in the sense that if you are sending out a bunch of broadcasts, you're going to slow your network down. Again, it's used to locate, and a broadcast is all ones. The MAC address set to all ones. Collision domain. So when you're building a network, you kind of want to separate into different broadcast domains, being like a switch here, switch there, switch there. A layer 3 is where it will separate them. And then the collision domain is like if you, I don't know who's using a hub now, but if you had a hub, that would be all of the ports on the hub would be in the same collision domain, and they can't talk at the same time, and they're sharing the bandwidth between them. Okay. So, like I said, this is a bit complex, but if you do want to learn about network architecture, networks, how they work, the OSI, TCP, IP models, great. they do kind of look confusing, but if we look at them really, like basically, I think I have a pointer. Yeah. So basically, OSI, TCP/IP. You, as developers, I don't know why there's that there, but you'll probably understand like these layers a bit better. Obviously, you're understanding these a bit better. I want to look at more these, so layer 1 to 3, touching on 4 only because of a router. But yeah, so it's like the physical, data link, link local, MAC, and network is kind of more what I understand. I'll talk a lot more about frames, I guess, than necessarily the other things. You want to look at, what equipment, where does it go, what layer is it on, and what's the actual point of it. Technically, their SI model goes to 7 layers. A lot of people like to say 8, 9 is like people and cost and all of that fun stuff. I'm a tech, so I don't really care about people. No, I'm just kidding. I do. The purpose, the equipment purpose, and what it actually does is kind of the beneficial part. I'm hoping to clarify that because it's all fine and dandy if you set a network up, but if you don't know what it's supposed to be doing, your design is going to be quite not lovely. So again, that's what I'm going to look at, the network, internet transport layers, and frames, and all that fun stuff. So, to start off, privacy by design. These are, I googled it, 7 principles of privacy by design. It's quite common for everything you do, especially with GDPR and Article 25, and it's you have to implement privacy from the conception of the idea, not post. Meaning, like here when it says number 1, prevention. When you're designing a network, when you're designing a product, when you're designing software, you have to think from the beginning. How can you reduce the impact? How can you enable a human-focused, human-centric, user-centric, privacy procedures, controls, all of that fun stuff. You want to minimize the possible problems. So that's prevention. You want to look at it from the first beginning. You're putting constant, what is that called? Something controls. You want to mitigate the impact before something happens. You don't want to do like Equifax, where you've built essentially a flat network, a flat environment where you get in once, you can traverse everything. You want to have controls in there to minimize that. Same with Target, for example. They got in back in 2013, so it's quite a long time ago, but they got in through the HVAC account and then had access to the payment network. That's bad. What we want to do is we want to separate that all out as best we can. It should be privacy by the default, so without even beginning your development, you want to think, okay, how can I reduce this? I bring up the example often of, what's that app called? Grindr. It's a dating app for gay men. Developers of that, obviously, they didn't want to cause any issues. They wanted to connect men to be able to date or meet up or whatever their reason was. But it was also used by people maliciously to attack those gay men. One man in Texas was targeted by trying to ask him on a date, and he was physically and verbally abused by 4 men in Cairo, Egypt. The police used it to target gay men because technically it's not illegal, but they didn't like him. So I like to bring that up only because it's like, as a developer, they were building this app, they were connecting people that wanted to be connected, but they have to remember from the mindset, from the beginning, how can it be used maliciously? And that's where they embed it into their design. My prior role was with ultra high net worth, high profile, and celebrities. Number 4 on there is that when I was building them secure communications, secure networks, secure whatever, the biggest thing is, whilst I needed to put these controls in place, it couldn't lack the usability that they needed. They still needed to be able to post on Instagram. They still needed to be able to go on their Facebook and that, but they needed to do it in a safe manner. So I had to implement controls, but also awareness, while also giving them the functionality that they needed, because otherwise they'll go around it. again, full life cycle, that's like encryption, end-to-end encryption, all that fun stuff. I don't need to explain that. You need to be visible, transparent, and you need to have the respect for the user and their data. So again, going back to Equifax, that data was very, very, very valuable, and so it needed to be treated a lot better than it was, and the risk needed to be understood better. Flat networks. So most networks I see are flat. And the reason for this, again, as you see on the screen, is the theory is it will reduce the cost, it will reduce the maintenance requirements, it will make it just work. Because the biggest thing when it comes to tech is what I realized when I first joined technology was if I didn't have something working, they're like, what the hell are you doing? Like, just get it to work. If it was working, they're like, what are you doing? Like, everything's working, you're not actually doing anything. So, kind of sucks, but people view technology as it needs to work. They don't care how it works, it just needs to work. Often your home network is in one broadcast domain. That's how it is. You have your router from the ISP, you plug it in and everything plugs into that. The downside to flat networks is it's really hard to be secure on them. It's hard to minimize the communication between everything because it's flat. They're all talking to each other. There could be possible speed issues. There's a lack of redundancy. And the last one is if you get malware, it can go everywhere. Same with ransomware. So probably don't build a network that's supportive of ransomware and supportive of malware. Another one that I often find people get quite confused by is virtual local area networks, so VLANs. A VLAN, if you look at it, is simply saying it's a LAN, but doesn't need to physically be connected to each other. So you can have two switches, and on this switch, I think my example has that, yeah. So on that switch's port here, it's got VLAN 50. On that switch over there, that one also has VLAN 50. Like, it's just a local area that's virtual. There's nothing fancy about it, but the nice thing is I can, through configuration, block VLAN 20 from talking to VLAN 50, even though they're on the same switch. You know, like they're on the same local area, but I can segregate them through software. And that's great because things like VLAN 50, maybe that's my management network, and I don't want my users on my management network, and I don't want certain devices on my management network or be able to talk to. This is great for things like because we have all this IoT in our environment now, they like to call home a lot. They like to just chat with the world. You quite often, you want to limit that communication. Think of the privacy by design. You want to minimize any impact by also reducing. And I mean, simplifying, because that for me is quite simple. I have a bunch of small VLANs versus one giant network that I don't really know what does anything. Okay, so now I'm going through I'm kind of rushing through this, so if you have any questions, just ask. But this is a typical home network, as an example. So a Soho router, if you don't know what it is it's the router, it's the switch, and it's the access point all into one. Depending on which version you have, they might have a bit more capability, but they're quite reduced in their ability to be secured. They're quite reduced in their ability to manage. It's mainly just a plug and play. Unfortunately, they're not very secure. Often they'll have default passwords or hardware password or things that are put in place that really is just because it's easy to roll out and it works. So typically in your environment, you'll have your phone, your TV, your computers all on the same LAN. You'll have guests come over, they'll all join. You'll have your, smart fridge on the same LAN. Everything's communicating. It's quite noisy. Considerations you can have is something like this. It looks super complex, but it's not. So the reason I bring this up is, so I'm going to pretend that's a Soho router now. It's a Cisco icon, so it's not actually, but we'll pretend that's your router, your switch, and all that fun stuff that you get from your ISP. What you can do, and what I like to do, is implement a switch in there that could be a layer 3, could be a layer 2, whatever is available to you, and then you can segregate things like, your your desktops, because they plug in, they can be on their own VLAN, or they can be plugged in, and then you can put a access point here, and you can say, okay, my family's devices are allowed here, and my guest devices are allowed here. And the reason that's quite beneficial is because you're looking at, you can limit things like certain kinds of traffic. You can say, these can communicate, but only in certain protocols or certain things. And maybe I want to give them internet, but they can only have internet to, like, websites, because they need to check their Facebook, but they can't have, access to certain things. And the benefit here is because if you're conscious, you want your home to be secure. You have your family photos somewhere. You have intimate photos. You have children's videos of, like, I don't know, they're growing up, and you want to keep it secure. You don't want to get hit with ransomware, and your guest comes over and they're like, I got this new phone from China, it's awesome, and I don't patch, that's a waste of time. Then you're opening yourself up to, you're agreeing, lots of people do that. My phone's from China. And you're opening your home network up to more issues, even though you're actually taking the time to care about it. So, don't trust your friends, block them off, keep yourself secure. I don't have friends, maybe that's why I do it. But it's a really good concept to consider is, you're putting the effort into it, so why don't you also mitigate it with different things? Add in the multiple SSIDs, which a lot of times the Soho routers either say they do, but don't actually, or don't actually let you do. Sorry. It's really annoying. I can see it. And then after that is also, get the foundations right at home, and then build from there. Add in, like, smart devices, IoT. Make sure your fridge isn't talking to your I don't know, laptop. I don't know. But it just, try and segregate as best you can, because networking, whilst people think it's this hugely complex thing, it's simply connecting the dots and making sure that the things that need to talk, talk, and the things that don't need to talk, don't talk. So the things that you can do at home that are quite simple. One example is having something like Pi-hole or OpenDNS. It allows you to view the traffic going on, see what's potentially malicious, potentially not, understand overall what your network is doing. Wireshark is great for that because it's free, and you can inspect your packets. You can kind of understand them a bit more. You can build your own little baseline for what is normal for your home, and allows you to kind of improve from there. And then you can take it to work, because now you're understanding what's normal, and you can ask the questions from the network people without sounding silly. I like Ubiquiti and Cisco Meraki products because they're decently priced and they do a good job for my home. I'm not saying that's the only solution, obviously, but I personally quite like them. That's why I use it as an example. Again, I'm not expecting you to go home and build this ridiculously brilliant network that costs as much as an enterprise one, because you're not going to be able to maintain that. That's bloody expensive, and it won't be as fun. So something like Ubiquiti has, quite good user experience. There's a lot of documentation online, as well as, they look pretty, versus, buying a Cisco switch that racks. I mean, granted, my personal home, I might have that, but I'm weird. And they're not as, user-friendly. They don't have the nice user interfaces. So next steps. So once you've built your beautiful little network that's segregated and not allowing your guests to talk to your fridge, then you can start researching ACLs, so access control list. You can look at filtering, next-gen firewalls. There's two examples I used, Soho boxes, for example. I don't know what, yeah, this one. That's free, and it's great because, like I said, it's free. I think I have can I view it here? I think I have it open. Oh, I didn't. Let me see here. Can I show view options? Oh, whatever, I'll show it later at the end. But it's, yeah, there's a home edition. It's basically, they describe it as our home or free home use firewall. It's really good because it allows you to kind of learn the basics, the foundations, without costing you a lot of money. That's kind of off the page. But now we move to an SMB network. So if you look at a home network, that's quite complex for a home network. Quite nice, quite pretty. Then you go to an enterprise network, and you realize I don't have a router in there because I have a layer 3 switch, but you realize right away it's quite similar. It's just on a bigger scale and more expensive equipment. But so we're looking at, you've got your firewall, whatever, and then you have in this case, I have a layer 3 switch. And a lot of networks now don't use routers as much. They'll use a lot of they'll have one router, which I don't even have in here. I would always put a router there, but I was lazy. But then they have, for routing, for minimizing those broadcast domains, they'll have layer 3 switches, because the cost at this point isn't a big difference. Switches, they're great at doing what they need to do, and routers are great at doing what they need to do. And so it makes sense to just have a router and then a bunch of layer 3 switches, because they can connect, they can chat, and the cost isn't exceptional. Because it wouldn't make sense in a small environment to have a crap ton of routers, because those are quite expensive. So anyway, so again, we're looking at the considerations. We're looking at, separating out the printers, for example. We're separating out the AV, separating out workstations, guest Wi-Fi, servers, data centers, all that fun stuff. So again, just getting back to it, the example is we just want to segregate. We want to segregate. We want to make talking to different VLANs challenging. And when it comes to reliability and that, we can add in a bunch of different of these, like multiple of them, that can then do load balancing and all of that fun stuff. So again, segregate systems, services. You want to implement things like logging and monitoring, because that will help you kind of understand what's normal, check what's unusual, what systems are trying to talk to each other that shouldn't. You want to have proper things in place to support your network, because a lot of times I go into a client, they implement this network, and then they leave and they're like, oh, it works, it's fine, and they don't maintain it. Shockingly, Cisco devices or Juniper devices or whatever network devices, they do actually need to be updated every once in a while. You will make changes to them. You need to pay attention. You need to document. And the biggest thing that I don't have written in there, but I actually have written somewhere else, is the biggest thing that I find people make mistakes on is explicit requirements. So Cisco switches has something called CDP, which is like, I can't remember what it stands for, but essentially switch and a switch tell each other, oh, I'm a switch or router, I'm a router, I have this IP address, etc., this information about me. By default, that's enabled. As you can imagine, that's a lot of information, valuable information if you're intelligence gathering. If you don't disable it or just assume it's disabled, it's going to continue talking. If you're not doing logging and monitoring, you won't know it's talking. Or if you've disabled it, you think, and then you update, or maybe it's the default is to disabled, and then you update your router or your switch, it might turn it on. So it's always great to actually, by default, have things disabled. And the last one example before I get into the common threats and whatever is a distributed hierarchical network. This is like the ultimate of ultimate networks. This is reliable. This is scalable. This is optimal functionality. It allows you to overlay security and unified communications, and this is what you want to ultimately get to in a company. You have the core. You have the distribution. So the core is chatting out with who it needs to chat with. The distribution is connecting everything, so it makes it very reliable and doesn't overwork the other ones that are communicating. It kind of just keeps everything flowing nicely. And then you have the access, which is, your users and your devices chatting and being able to actually connect to the rest of it. In a lot of organizations, this is a bit of overkill. So the reason I've got this little box here is in a collapsed environment, you would have the core and the distribution in the same. So those routers, 3, would actually be doing the core as well. But then you also still have the access ones that kind of allows it to be more, it allows it to still be reliable, still be scalable, but it's a bit of a reduced cost. So now let's get to the fun stuff. Common attacks and mitigation. So I've got, it's about 15 minutes left. Okay, so I have my slides are not very pretty. I have very small little common attacks. These are common attacks on network. There's the MAC address flooding. Why are you doing that? Okay, apparently it doesn't want to let me. Let's try this quickly. Play from current slide. There we go. I don't know why it's doing that. Okay. So I've got the MAC address flooding, the DHCP spoofing, DHCP starvation, what I mentioned earlier, CDP, brute force password attacks, and VLAN hopping. So those are really common attacks. So how do we mitigate this? My number one favorite thing to do is port security. I just put a bunch of commands out there to kind of explain to you what port security is, but essentially on your switch, you're enabling port security, switch port security, that you can shut down the ports you're not using. You can, this one here is the MAC address. So that's going to help against flooding because you can do static. You can only set, well, this port has this MAC address, or this port, Max has 2 MAC addresses. It can either be this one and this one. So when a malicious person, maybe a pen tester, comes in and plugs into an open port, it's not going to actually let it work because they don't have the right MAC address on their device. Sticky I quite like personally because I don't need to memorize and physically type it out. I can say sticky and you plug it in. Maybe you say 2 MAC addresses are allowed. It's my desk, so I plug in either my desktop or my laptop, for example, and it memorizes those MAC addresses. This one here, violation. So what does it actually do after? The reason I put the question mark is because just like in a man page where you do, help or whatever, it will then give you the options and then give you a description about it. This is obviously in the command line, but it gives you the 3 different options: protect, restrict, shut down. So I generally do shut down because if somebody malicious is plugging into a port, it's obviously not the one I want it to be. That port is then shut down and the administrator has to re-enable it. Often people don't like that because it does require maintenance. It does require the administrator login and re-enable it. However, they might use an option like protect or restrict. Another couple mitigations are, again, disabling unused ports. Really, really simple. Just log into the switch and turn them off. That's all you have to do. I like to show the range because a lot of people don't realize. Obviously, this is a Cisco switch because that's my background. I'm sure the other ones have the option, but you can also put a range of switches. Like you can go port 24 to 38. If they're not being used, you can go to all of them, shut them down, be done with it. Disabling CDP, you can do a global no CDP run, and that one's awesome because that disables CDP globally, and then the ones you actually want it on, you can manually go in and turn it on. So that's what I mean by an explicit command. I'm explicitly writing in the running config or startup config, you want to save it, so startup config, that I don't want this to run. And then again, I cover it again, but things like SSH, for example, there's version 1, version 2. By default, it allows both versions, so you might explicitly want to say only use version 2. ACLs, you can limit access to V2I lines. Again, that might be that's a bit further than the basics, but that's what you can start considering next. DHCP spoofing or snooping. So, as you saw earlier, you want to configure the DHCP server, and you need to enable the VLAN on a trusted interface. So you have to have that configured, and then the database agent, and then it just, you enable it globally. That will help against the spoofing and starvation. I assume you know what those are, but I can quickly cover that. Spoofing is, where I actually wrote out the definitions in case you want me to go through it, but yeah. Just to give a quick, in case you don't know, starvation is just using up the IP addresses, so the next client wanting to connect doesn't get one, and that generally I'll do that before doing the spoofing, because then that client will then be looking for a new DHCP server, and then I can put my malicious one in there and it will easily connect. Or you can just do that one, the second one originally, where you have a malicious DHCP server. So that's when you would want to do that. Yeah, so you'd want to be able to say it's only on trusted ports. So basically, me, the malicious person, can't then put my own there, if that makes sense. And then switch spoofing. This one is, if you're going to implement VLANs, as I said, they're excellent, they're really effective, but you need to look at this next step of, because of VLAN hopping. So the first bit is, implementing, segregating, and then also making sure the malicious hacker can't just, bypass it. Just like when you put password policy controls in place and people just bypass it by adding an exclamation mark because they don't want to change their password. It's just something simple like that. For this one, it's no negotiate, meaning, I don't know if you know what a trunk and access is between switches, but a trunk means all of the VLANs can communicate back and forth through these, and access is only the ones you're enabling, or it can't become a trunk. And so no negotiate means you can't change that connection to a trunking port versus an access port. So you want to say, or vice versa. So you want to say no negotiate, and then access. The other biggest thing here is don't ever use VLAN 1, because that's the default VLAN. If I'm going to attack you, I'm always going to try and use the defaults to then get around figuring out what you have configured. And then you can set the native VLAN. So basically the packet, the native VLAN is if the packet doesn't have a VLAN assigned, it just uses the default one. You can manually set that VLAN separately, so that if people are using that, joining your network and using it, it means that maybe you can get them to bypass everything and they only have internet access, which is quite common, or it doesn't allow them to connect to anything. So they won't necessarily realize why they're not connecting. It's just not letting them communicate, even though the port still stays up, for example. And then, I've forgotten E, but again, on the specific interface, it's switch port trunk native VLAN. VLAN number. On the global, it's VLAN.1Q tag native. Okay, my last bit, good timing actually. My last bit is the best practices. I think this is my final slide as well. So, obviously, we touched on the very basics of networking. There's way more complexity to it. Actually setting it up and plugging it in, that would be its workshop in itself. But these are some really good principles, ideas, ways to start when you're building a privacy and security by design network. So the principle of least privilege, again, reduce people's access to it, obviously through their accounts, but also another consideration is, if they need access to the accounting VLAN, but not the HR one, then don't give it to them, or like their device, or, separate the management VLAN from the regular one, or the guest from the corporate users. Always have documentation. A big problem that network architects have is, especially in incident response, I come into an organization that's been breached and I say, okay, what's your topology? And they're like, there's a server room. And I'm like, okay. Are you a do you have different VLANs? Is it a flat network? And they're like, the server room is that way. And then you'll be like, okay, well, has anybody made any changes recently? And they're like, seriously, like it's over there, because they have no documentation. They don't even know what their, IP address scheme is. They don't know where, what the last configuration change was, if it was a malicious one or intentional, because it just wasn't maintained. I've been in a situation where somebody with good intentions made a change, went home and went to sleep, and then we didn't know if we were breached or if it was an intentional change or what happened because nothing was working. And it was simply because they didn't document it, and then they had to wake up at like 2 in the morning and we're not happy. Again, shut down unused ports. I put HTTP old things, encryption, etc. Basically, if you can use a security protocol on something, then use it. Like, don't use the unsafe one, because basically, if you do a span on a switch, you can basically rebuild anything. Like an example that might make sense to you is somebody was having issues on their network. So they sent their instructor a PCAP file and said, okay, I'm not really sure what's going on. Can you review this? And they're like, yeah, no, that's awesome. And they redid it, and they ended up actually rebuilding a VoIP conversation where they were talking about highly confidential information. I think it was, what's it called? Where a company was buying another company, acquisition, I think, and that they're not allowed to, that the employee themselves didn't make enough money to know it, never mind this instructor that didn't even have permission to access that. And so they all were in quite a bit of trouble, but it was simply because they didn't encrypt their VoIP communications. So is it really never going to stay? Oh, sorry. That's really weird. Yeah, there was actually a point to that. So basically, when you can use security, layer on the security, because you want to segregate, but you also want to add in more controls, because eventually something is going to fail. As an ethical hacker, my job is not to succeed all of the time. All I look for is that one time that you failed, or that one time I can succeed, and then I'm good. Do regular validation. This is things like test the configurations you've put in place. Use things like vulnerability scanners, because, again, you can get them for free, and they're constantly checking versus just doing, I do an annual pen test. I had a client that did an annual pen test, and then they were breached, and they didn't investigate for 2 months because they didn't really know what to do. And that's not great, but it's just a snapshot. That's what an annual pen test is. It's a snapshot validation versus in between that annual pen test, you're going to have your topology change because, as you update, install patches, make configuration changes, your landscape does change. So make sure you're doing regular reviews. Do effective awareness training, not just on what to do and what not to do, but also how to implement these things effectively, looking at human behavior, intrinsic motivation versus extrinsic, like intrinsic being, I want to be a part of something bigger, I want to make a difference, and therefore I'll actually care about these security controls, versus you click that phishing link, so I'm going to, punish you, because that's not going to be long-term interest, long-term awareness. Again, segregate as much as you can. Call your mom, yes, that's great, but don't have your IoT device talk to your computer, for example. Monitor DNS queries. You can block quite a few malicious links through that. Brand new domains being implemented, or known malicious domains, blocking those through software, through controls. It can be quite a big positive impact. Remove default passwords, and again, when you're writing your configurations, write, yes, I want this, no, I don't want this. Think of it kind of like an ACL. Think of it kind of like a firewall rule. In your mind, you want to say, deny everything, and then only enable what I want. And the last one is the 20%. They say you should spend about 20% on your yearly costs towards security. in an organization, that makes more sense, obviously. But essentially what I'm trying to say there is be proactive in your design, be proactive in your controls. You don't have to buy the sexiest, coolest software and hardware. You just have to implement it effectively and actually understand what it's doing. That is everything that I have to say. And I think it was exactly 40 minutes. Let me know if you have any questions, but that's it. Thank you.